Okay, hello. Welcome to my talk on Prometheus monitoring for Java web applications without modifying source code. So as the title says, what we are going to do in the next half an hour, we are going to instrument a Java web application with Prometheus metrics, and we are going to do so without modifying the application's source code. So 30 minutes is not very long for this topic, so I cannot really give you a huge overview of what Prometheus is and the ecosystem around the Prometheus server and how monitoring works in general, and then also talk about instrumenting Java applications without modifying source code. So what we're going to do, I'm going to keep the introduction very, very brief. I'm just going to say what Prometheus metrics actually are, because that's what you need to understand to follow the talk. And then we go right into the Java part. And most of the time we will be looking at Java code and learning how to instrument Java code without code modification. Okay? So let's start. What is a Prometheus metric? So Prometheus, what you need to know, the Prometheus server is a time series database. Okay? So the basic data structure of Prometheus are sequences of floating point numbers, of 64-bit floating point numbers that are stored together with the timestamp when those numbers have been observed. Okay, and the best way to show to you what a Prometheus is, a metric is, I guess, is by example. So I have this little example application here. It's called the Wildfly Kitchen Sink. There's nothing special about it. It's just that if you go on GitHub to this Wildfly/Quickstarts repository, you find a whole bunch of applications, each of them illustrating a different aspect of Java EE. And I just picked the kitchen sink as my example application. So it's a very simple application. It has a REST interface. You can access that here. And what it does, it loads a list of members from a SQL database in JSON format. Okay, so nothing special about this application. It's just what I will use as an example throughout the talk. I'm going to run it on the Wildfly server. However, everything that I'm going to say also works with Tomcat and Spring Boot, for example. So actually, real like Java EE application servers make those things a little bit harder. So if it works with a real Java EE application server environment, chances are good that it works as well with something more lightweight like Spring Boot with Tomcat. Okay? Good. So what's a Prometheus metric? So the simplest metric you can think of for an application like this would be a counter counting the number of times that this endpoint has been accessed. Okay, and I actually have this application instrumented for Prometheus right now, and I have a Prometheus server running here. So what we see here is the Prometheus debugging API. So if you start the Prometheus server on port 9090, it has a built-in debugging API that you can use to run some queries and verify that everything's running correctly. Okay, and I have a metric called HTTP requests total. So I can type this here, requests total, which is my counter of the number of requests. So if I run this query, I see that there's more than one metric with that name. And those metrics do not only have a name, they also have labels, okay? And one of those labels is the path here. And as we are only interested in this /members endpoint, that's what we're going to instrument in this talk. I can refine my query a bit, can say, I'm interested in metrics that have the name HTTP request total, and they should have a label named path. And this path should match anything ending in members, okay? So if I run this, I have only one result left, so this is my counter. So it has a name, has a bunch of labels, and a value, which is a floating point number. So what we see here, up to now, this endpoint has been accessed 620 times. The counter is so high because I have a small shell script running in the background, polling this endpoint every second so that we have some traffic to see something, okay? So last word of introduction to that. I mean, so this is the format of a Prometheus metric, okay? Question is, how is this useful? I mean, how can it be useful to know that this endpoint has been called 620 times? And of course, this information in itself is not useful at all, okay? However, you need to be aware that the Prometheus server is a time series database, so it does not only store the current value of this counter. It also stores the history of all previously recorded values, okay? And I have configured my server such that it polls the values every 15 seconds. So every 15 seconds, I have a snapshot of how this counter evolved. And what I can do now, for example, with the Prometheus query language, I can say, let's look at a time interval of the last 5 minutes here. And then this query language has functions. One of them is rate, which takes a time interval as parameter and gives me the per second rate as a result. And if I run this, I see that if I look at the time interval of the last 5 minutes, I can say that my endpoint has been accessed with an average rate of almost 1 request per second, okay? And this is the type of information that makes Prometheus useful, you know? So knowing the current load on your system can be really valuable. You can define alerts if there is overload or something unexpected is going on. And of course, you can relate this to other metrics that you have and so on. So this is the type of way Prometheus works, right? But from the application point of view, so all you need to do is you expose some floating point values. There are counters. There are also histograms, for example, for measuring time intervals. And all the actual magic is then happening in the Prometheus server. So that was a very, very quick Prometheus introduction. And let's now look at some code and discuss how would you instrument a Java web application, okay? So this is the source code of this kitchen sink example. There's nothing special about it. And before we will actually go ahead and instrument this without modifying source code, we will first instrument it with modifying source code so that we later know what's going on, what we are doing, okay? So what we are going to do, we are going to stick with this simple counter example because it's easy to understand and everything else works very similar. And this little method here, list all members, is the implementation of this endpoint that we looked at. And what we're going to do, we are going to instrument this method with a counter, counting how often this method was called, okay? How would you do that if you can actually go ahead and modify the source code? Of course, first things first, you would start adding a Maven dependency, of course. So this is the POM file, and I'm going to say, I'm adding 2 dependencies here. First is the IO Prometheus simple client. It's a Prometheus client library for Java, and this is where the metric types are defined, like the counter that we are going to use and other things for measuring time intervals. So it's a simple Prometheus client library. And then once you have your metrics available, you somehow need to expose them to the Prometheus server. So Prometheus uses HTTP requests to load, to pull the metric from your application. So your application somehow needs to provide an HTTP endpoint for the Prometheus server to make the metrics available. And there's, of course, more than one way to implement this. One way is that there is a predefined servlet in this simple client servlet dependency. And for the demo, we are just going to use this. Okay? Good. So with the Prometheus dependencies up and running, we can now go ahead and just create, let's make it a bit bigger, our counter here. So the API is very simple. This is the counter metric. I'm giving it a name, HTTP requests total, a little help message so that we know what's going on. And then I'm going to give it only a single label named path, which is like the REST URL we are calling. And then I call register. So what's happening with register is the Prometheus client library has a global variable or like a static variable, which is a list of all metrics that are known to the system, okay? And register will just take this counter and put it to the list. And then later, when our servlet goes ahead and exposes the metrics, the servlet will just go through the list and expose everything it finds there. And that way you can basically just define metrics wherever you like in your code. As long as you call register, it will be in the list and it will be included in the exported format. Okay? So, and now that we have our counter, we can just go and say HTTP request total with a label value /members, because that's the endpoint we are instrumenting right now, increment. Okay? So it's fairly easy, nothing fancy here. If we want to try it, of course, we need to configure our servlet because otherwise we don't see much. So we can do this old school with WebXML. There are more modern ways, I don't know. So this is very simple. So I'm just going to say I'm taking this servlet implementation, the metric servlet that comes from the Maven dependency I included, and I'm going to map this servlet to an endpoint / metrics. Okay, so let's try this. Let's just quit our previous example so that we don't get any port conflicts. And example 1. So this is a little shell alias. What it's going to do, it's going to compile the kitchen sink application to a WAR file and then start a new Wildfly instance and deploy it there. Okay, and while Wildfly is starting up, maybe a few words about this one here. This actually works. It's also okay, like if you have production only code, but it's not very good coding style. Okay, because what happens now, I mean, if you just want to use your code that way, it's nice. But if you want to write a unit test, for example, and you want to create a REST service instance for testing, and you don't want to have the counter there, or you want to replace the counter with a mock object or so, this will be very difficult to do because it's really hardwired now if you create a private static final variable here. Okay, so what you usually would do in a real-world application, probably you would create your counter somewhere else in some application scope bean or so and use dependency injection to have it available here. And then you can also replace it with mock objects for testing and so on. So you can structure it more nicely. But for the sake of the demo, like from the functionality point of view, it's the same. Okay. So Wildfly is up and running. And what we see now, we can access our endpoint again, still responding with the same response. So we don't see much actually. But if we go now to port 8080 and the /metrics endpoint, we see that we have, so this is the exporter format that the Prometheus server can understand, and we have our metric here with that name and that label and the value of 1. Okay, if we reload the endpoint, reload this, then the value now is 2. Okay, so this is nice, very straightforward. There's nothing interesting or nothing special about instrumenting Java web applications when you can just put some metrics into your code. However, sometimes you need to monitor things where you are not allowed to do this, okay? Not everybody who has to monitor an application can just add some Maven dependencies and throw some metrics into the code somewhere, okay? So one technology that you can use to actually do this thing, if you cannot modify the code, is you can write your own Java agent. So this is what I'm going to show you now. The wrong one. This one. Okay, what's a Java agent? So Java agents actually are nothing new. They have been around for a very long time in Java, okay? And a Java agent is basically a jar file, which is pretty similar to an executable jar, a regular jar file that you can execute. And what you do with an agent jar, you can attach it to a Java virtual machine, okay? So when you start a Java program, you can use a special command line parameter called -Java agent, and then it has the path to the agent jar. And if you use this, your agent jar will be attached to your JVM. And whenever classes are loaded in the JVM, the agent will jump in and has the opportunity to modify the bytecode that is loaded on the fly. So we will see in a minute how this works, okay? So how does an agent look like? It's very similar to an executable jar, but just the same way as an executable jar has a main method, that's like the entry point to the application, an agent has a pre-main method, and this is executed before the actual main method of the Java application, okay? And what does the pre-main method do? It has 2 parameters. The first one here is just to pass command line arguments in. It's not very interesting. Interesting one is the second here, this instrumentation object that the JVM gives you. And what you can do with it, you can call add transformer to register a class file transformer. Okay, what's that? Class file transformer is actually a functional interface. So I could use a lambda expression here if I liked. Okay, has just one method. It's called transform. It has a whole bunch of parameters, but the interesting one is the last one here. It's this class file buffer. So what happens is, whenever a class is loaded in the JVM, of course the class loader reads the contents of the .class file, which is the bytecode defining the class. And then before the JVM goes ahead and interprets the bytecode and actually creates the class, the unmodified bytecode as it is read from the class file is passed through all agents that are attached to the JVM, okay? So what you can do now, you could, for example, go ahead and just return the class file buffer here. In that case, your agent does nothing. It just passes on the bytecode as it is. But what else you can do, you can go ahead and say, I'm going to create my own byte array with some modified bytecode. Okay, and then you have some code to initialize that, and then you return this. So what happens now, whenever a class is loaded in your JVM, the JVM does not actually see the bytecode that is defined in the class file. It sees the bytecode that you return here. And this is interesting because this provides you an opportunity to sneak in some functionality that has not been there in the original class, okay? And we're going to use that to sneak in some Prometheus metrics into Java web application that didn't have Prometheus metrics before. As you can imagine, if you do it on that low level, it's a bit error prone because you cannot really shift byte arrays of bytecode around without having some bugs and some weird errors. So fortunately, you don't need to do it that low level. There are libraries around that have a bit more high-level API that help you doing these things, okay? And my favorite library for doing these things is called Byte Buddy. So instead of writing this code, you can use an agent builder that's provided by Byte Buddy. Okay, let's just import this. This is a static method. This is also a static method. Okay, so and this is a very nice library. It provides you a really readable API for implementing Java agents. So what you do is you use the Byte Buddy agent builder. Then the first line here is type of a filter. You tell Byte Buddy which classes you want to instrument. Okay, so I'm going to instrument all classes that have a supertype named JavaX servlet servlet. So I guess everybody knows what a servlet is. Okay, servlet is an interface defined in the servlet specification. The interface has, among other things, a method named service, and this method has two parameters, servlet request, servlet response. And this is involved, like an implementation of the servlet interface is involved whenever a Java server handles HTTP request, okay? So no matter if you have REST with JAX-RS or SOAP with JAX-WS or JSP pages or Java server pages, it's all built on top of the servlet standard. There's always a servlet involved. So if we sneak in our metrics into all implementations of the servlet interface, chances are very good that we capture everything that's interesting, okay? And what are we going to do? We are going to instrument the method named service, okay? And we are going to instrument it with an advice, which is called demo advice. So what's an advice? Let's look here. Advice is a Byte Buddy concept. So it's basically a Java class with a bunch of static methods. And those methods are annotated with onMethodEnter and onMethodExit. And what will happen now when Byte Buddy instruments the classes, it will take this code and copy it right to the beginning of the servlet service method. And it will take this code and copy it right into an artificial finally block of this service method, okay? So the first code is executed right when we enter any service method in any servlet implementation, and the other code is executed right before we leave the method. So let's try this. Let's go to the right window here, example. So what this shell alias is doing, it will compile the code that I showed you into an agent jar and then start a new Wildfly instance with this -Java agent command line parameter. So the agent jar gets attached to the Wildfly server, and then it will deploy the unmodified kitchen sink application. Okay, so how do you create an agent jar? This is exactly the same as an executable jar. So I'm creating a fat jar here, so jar file with all dependencies included. I'm using the Maven assembly plugin to do so with the predefined jar with dependencies deployment descriptor. And just like an executable jar has a manifest file that defines what the main class is, we have the same manifest file here, and it defines what the pre-main class is, okay? And this is the class implementing the pre-main method, okay? So exactly the same as an executable jar. Okay, so our server is up and running, and if we access our endpoint again now, we see, okay, so I wrote these messages to standard error, so we have some little red lines now indicating that our agent is actually attached and doing something when we run some HTTP requests. So this is interesting, so let's go ahead and make something useful with that. So what we can do now, we can say, we create our counter, again, the same code that we used when we actually implemented the application. Here we are going to say we take this counter, and with a label value, we can actually read the path from the servlet request here. So we cast it to an HTTP servlet request because we know in the demo nothing else will happen. And then we call get path info that gives us the path, and we say increment. Okay? There's one little caveat. This code will be copied into the implementation of the servlet interface, and then the reference to this variable will no longer be in the demo advice class, okay? This code will be in the servlet implementation, so you actually need to make this public to make this work, okay? And then, of course, we need to expose our metrics somehow. So I could use a servlet again, maybe create an extra war file that's just there for the purpose of deploying it next to our application and making the metrics available. In order to save some time, I will do a very quick hack. I will just go ahead here and start an additional HTTP server just for the purpose of exporting metrics. So let's just, is there an import everything in IntelliJ? I don't know, or do I have to click? So I can show you in a minute what it is. So actually the Java runtime comes with a built-in HTTP server. I don't know if it's safe to use that because it says comsunnet, whatever that means, but it's included in the Java runtime. You can start it here on port 9300, register an endpoint /metrics, and whenever this endpoint is accessed, we are going to say we go to this collector registry, which is the global list of all metrics available. This is like this Prometheus concept that I was talking about, and we just write all metrics in that registry to the HTTP exchange. So we have a very simple exporter server going on here and don't need extra war files to deploy, okay? And let's not forget to actually call this, okay? So just at the end of the pre-main method. So let's run it. Actually, the code that I showed you is really complete, which is cool. So the only thing that I didn't show you is, in order to make this work with Wildfly, I'm setting an environment variable called Java opts, okay? I will show you in a minute the contents of the Java opts, and then you have seen everything that's that's necessary to understand this, to really run this application at home, so to say. So let's just go ahead and try if things worked. So we can access this endpoint again. We see our nice red little lines here written to standard error. So our agent is attached to the application. And if we now go to port 9300 /metrics, yay, we see that our metrics are exposed again, okay? So current value is 1. If we just query this endpoint again, the value increases to 2. So this is interesting. This is a very powerful concept because with very few lines of code, you can actually write agents that do like magic things that most people are not really aware of, that you can actually do them. And I used the servlet interface as an example here for the demo. However, in exactly the same way, you can also go ahead and instrument standard JDBC interfaces, and then you learn about all SQL queries going on from your server, or instrument whatever standard interfaces you would like, okay? Like thread pools in order to know like the usage of your pools or whatever. So it's fairly simple to implement something like that with Byte Buddy, okay? So let's just the quick look at the Java opts environment variable. This is actually JBoss specific, okay? What I'm doing here, this whole code here that I marked is actually the contents of this Java opts environment variable. The interesting things are, of course, I specify the -Java agent here to attach the agent. this port at the end is not used. It's just there because I copied it from another example. So that's basically ignored. And the other interesting thing is this JBoss module system packages. Okay, actually, all classes that you put into an agent jar are available through the system class loader. Okay, so when I built the fat jar and had my Prometheus client library and my demo advice there, and this should be available in all classes because it's propagated through the system class loader. However, Java EE servers do not use class loaders in the way they are supposed to be used, okay? Java EE application servers block direct access to the system class loader. It's because they are supposed to run multiple deployments and you don't want to have conflicts and so on. So what JBoss does, in order to really make the system class loader work, you need to explicitly list all packages that should really be made available to the application. Okay, so what I'm doing here, I'm listing my prom agent where the demo advice is implemented, and I'm listing the Prometheus client library, of course, and that makes them available the way they actually should be available, and then things work. Okay, but you need to do this if you run this in Wildfly. So where can you go from here? If you actually go to this domain, promagent.io, you'll find my little toy project, or like the code that I used to learn about these things. And what I did then, I did an experiment. Instead of listing all packages there that you need, you can also say, okay, you just create a single package, and within that package you create your own class loader, and that class loader goes ahead and then loads all other dependencies. Okay, it's not really needed if your only dependency is the Prometheus client library. I mean, then it would be overkill, and you can just do the same thing that I showed in the demo. But as you gather more dependencies, I guess at some point it will become unfeasible to just list all packages that you need, and then writing your own class loader and loading the dependencies yourself is the way to go. Okay. What else? I mean, there are a few tricky things. For example, sometimes one servlet calls another servlet. In that case, this counter would count a single request twice. I mean, you can use, for example, thread locals to mark in the current thread that you have actually seen the request. And then when another servlet is called, you just look up in the thread local, learn, okay, it's already been registered, so I'm skipping this. So you can, like, there's little tweaks here and there that you need to do. But basically, I mean, if basically you can go very far with just the few lines of code that I just showed you. Okay, so that's it for my half-an-hour talk. There are 3 minutes left actually, so I can take a question. So, okay. The question was, where do I configure the URL? And okay, I shut down the Prometheus server. So the Docker container is gone where I did it, so I cannot show you, but I can tell you. There is more than one way how to configure a Prometheus server. Okay, the simplest way that I did is there is a YAML file where you just list all endpoints that you want to monitor, and this is good for simple scenarios. Okay. This does not scale if you have dynamic services running in Kubernetes and so on, because then you don't have constant endpoints. And then Prometheus comes with a lot of like service discovery mechanisms that you can use to, like, it has tight integration with Kubernetes, so it can learn from the Kubernetes master where your service endpoints are and so on. So this is all, like, Prometheus is very powerful with this. But for the demo, I just configured it in a YAML file, said it's on localhost /port 9300. Okay, good. Maybe one small question, 60 seconds. Okay, so thank you. There's one. Yeah. The question is, okay, the question is, in the demo advice class, I changed this to public, but I didn't write the full reference here, like this. The answer is because the bytecode of this here and the bytecode of This here is the same, okay? And Byte Buddy does the instrumentation after this class is compiled. It takes the compiled class code and then bytecode and puts that into the class to be instrumented. And after compilation, it doesn't matter if you put the reference there or not, okay? So, good. Thank you very much for listening. Have a great Devoxx, and goodbye.